why do elements form compounds? All elements want to have a full, stable outer electron shell like the noble gas elements found in group 8 of the periodic table. What we're focusing on is the energy levels and the maximum number of electrons that can occupy that energy level. This is where we have to look at the electron arrangement of that particular element. If the outermost occupied energy level is the first energy level, it can hold and wants to achieve a maximum of 2 electrons. If the outermost energy level is the second energy level, it wants to achieve and hold a maximum of 8 electrons. If the third energy level is the outermost occupied energy level, it wants to also occupy a total of 8 electrons. When different elements combine, a chemical reaction takes place and a new product is formed. For example, if we were to take magnesium, which is a grey solid, and react it with oxygen, which is a colourless gas, a chemical reaction would take place and a new product would be formed, which would be known as magnesium oxide. The D in "ide" stands for double, which means two different elements have chemically joined together to form a new compound. The chemical formula is the shorthand way of representing which elements you have in a compound and how many you have of each. The method that we are going to use to be able to work out the chemical and the ionic formula is using SVSDF, which stands for symbol, valence, swap, divide, and formula. The symbols for elements can be found in the periodic table, and the valency is the number of bonds an element makes to achieve a full, stable outer electron shell. If we take lithium for example, lithium has the chemical symbol Li and has the electron arrangement 2-1. Lithium will lose one outer electron to achieve a full, stable outer electron shell. What we should be able to see is that there is a link between the number of outer electrons and the group that an element's found in. Lithium had the electron arrangement 2-1 and is found in group 1. It loses one outer electron. Beryllium has the chemical symbol Be. It has the electron arrangement 2-2. Beryllium will lose 2 outer electrons to achieve stability. Those 2 outer electrons are directly linked to the group number. Elements found in group 2 will lose 2 outer electrons. So far, elements found in group 1 lose 1 outer electron. Elements in group 2 lose 2 outer electrons. At this stage, it's important for us to look at the periodic table as a whole. There is a line which divides the periodic table into 2 sections: metals on the left-hand side of the staircase and non-metals on the right-hand side of the staircase. Metals will always lose electrons to form positive ions. So metals found in group 3, such as aluminium, gallium, indium, and thallium, would lose 3 electrons to achieve stability. Unlike metals, non-metals always gain electrons to form negative ions. Elements found in group 4 have 4 outer electrons in their outermost shell. They need to gain 4 electrons to achieve stability. Elements found in group 4 have a valency of 4. Elements in group 5, however, such as nitrogen, which has the chemical symbol N and the electron arrangement 2-5, needs to gain 3 electrons to achieve stability. So elements found in group 5 will have a valency of 3. That's the number of bonds that they need to achieve a full, stable outer electron shell. Elements in group 6, such as oxygen, which has the electron arrangement 2-6, needs to gain 2 electrons to achieve stability. So elements found in group 6 of the periodic table have a valency of 2. Group 7 elements, such as fluorine, which has the electron arrangement 2-7, need to gain 1 electron to achieve stability. So elements found in group 7 of the periodic table have a valency of 1. That brings us on to the last group, which could be known as group 0 or group 8. These are a special block in the periodic table, which are known as the noble gases. The noble gases don't form bonds, and the reason is that they already have a full stable outer electron shell. This is the electron arrangement that all other elements in the periodic table are trying to achieve. The way that I remember the valencies going along from group 1 to group 0 is using a little song. The song goes 1, 2, 3, 4, 3, 2, 1, 0. So I'm going to go through a couple of worked examples showing you how to write the chemical and ionic formula for compounds ending in "ide". And this first example, we are going to work out the formula for sodium chloride. We start off with our SVSDF, symbol for sodium, Na, found in group 1, valency 1. Symbol for chlorine, Cl, found in group 7, valency 1. We swap the valencies over. What's the highest number both can be divided by to keep it a whole number? That's 1, which means to write our chemical formula, we write down our symbol for sodium, which is Na. How many of those have we got? We've got 1. But we don't write ones in chemistry, so we don't write a number after the symbol. Chemical symbol for chlorine, Cl, and again we've only got one of those, so we don't write a number after that. So the chemical formula for sodium chloride is NaCl. Writing ionic formula is a little bit different from writing chemical formula. Not only do you have to be able to write the symbol and identify the valence of that element, but you need to also show the charge of that element. The way that I remember this is like making a sandwich and wrapping it up. It's really important that we wrap it up. You wouldn't just make a sandwich to take to school and put it directly in your bag because the filling would fall out. The same thing happens when we're writing ionic formula. We don't want the charge to essentially fall out. Well, that's a little story that I use to help remember. Let's try sodium for our first example. The chemical symbol for sodium is Na. It's found in group 1, so has a valence of 1. Metals always lose electrons to form positive ions. 1 times positive is 1 positive. Remember, we don't write ones. So we put a positive after the chemical symbol. We need to remember to put brackets around it to wrap it up. We can do the same for magnesium. Magnesium has a chemical symbol Mg. It's found in group 2, so has a valency of 2. It is a metal, so will always form a positive ion. 2 times positive equals 2 positive. We need to remember to wrap it up, so to put brackets around it. When we come to non-metals, such as oxygen, oxygen has the chemical symbol O. It's found in group 6. It needs 2 electrons to achieve stability, so has a valency of 2. Non-metals always form negative ions, so the charge will be a minus. 2 times minus equals 2 minus. We need to make sure that we wrap it up by putting brackets around the symbol and the charge. We need to be careful when we're looking at a valency of 1. Let's take fluorine for example. Fluorine has the chemical symbol F. It's found in group 7, so has a valency of 1. It is a non-metal, so has a charge of negative. 1 times negative is negative. When we're writing formula, chemists never ever ever write the number 1. Not in the formula. We're very lazy. Remember, once you've got your charge and your valency combined, you have to make sure that you wrap it up. So ensure to put brackets around the outside. For the ionic formula, there's only one extra step, and that is make a sandwich, wrap it up. The symbols are exactly the same, Na and Cl, and the valencies are the exact same, 1 and 1. Remember, sodium is a metal, so it always loses electrons to form a positive ion, and non-metals such as chlorine always gain electrons to form negative ions. What we have to do now is we need to sandwich the valence and the charge. So for sodium, it's got a valence of 1, which is positive. 1 times positive equals positive. And now that you've made your sandwich and put the charge after the chemical symbol, we then need to put a bracket to wrap it up. We do the exact same with the chlorine, valence of 1, charge of minus. So the overall charge of the chloride ion is minus, and we wrap it up in brackets. We swap the valence over, we divide by 1, and this is the part that is really, really important. We need to write down the chemical symbols that we have above exactly how they are in their brackets. So we've got an Na positive in a bracket. How many of those have we got? We've got 1, so we don't write the number there. Then we have got Cl minus in a bracket. And again, we've got 1 of those. We don't write the number after the bracket. Now in past papers, the way that we've written the formula would be accepted, especially at National 5. But it's more common that if you only have one of a type of ion, which means that you do not have a number directly after the bracket, that we usually get rid of those brackets. So the ionic formula for this particular example would be Na plus Cl minus. We're going to do some examples now where we must keep the brackets in. This example wants us to write the chemical and ionic formula for sodium oxide. If a compound ends in "ide", the D stands for double, which means that we only have 2 elements present. We write down our SVSDF and insert the chemical symbol for sodium, which is Na. It's found in group 1, so it's got the valence of 1. Oxygen's chemical symbol is O. It's found in group 6, so it has a valence of 2. We swap those numbers over, and the highest number both of those numbers can be divided by is 1. 2 divided by 1 is 2. 1 divided by 1 is 1. We write down the chemical symbol for sodium, which is Na. How many of those have we got? We've got 2. So we write a small 2 directly after the chemical symbol. Oxygen, chemical symbol is O. How many have we got? 1. But we don't write ones. So for the ionic formula, the first couple of steps are the same. We write our SVSDF, our symbol and valence for sodium and oxygen. Remember, metals always lose electrons to form positive ions. So the sodium is going to be having a positive charge and the oxygen will have a negative charge. We need to make a sandwich and wrap it up. 1 times plus is plus, wrap it up in brackets. 2 times minus is 2 minus, wrap it up in brackets. The same steps follow. We swap over the valencies and divide by 1. But this time we have to write down exactly what we have written down for our symbol. So we'll do bracket Na plus, close bracket. How many of those have we got? We've got 2. Bracket O, 2 minus, close bracket. I always like to have a little double check to make sure that my answer is correct. The way that I do that for the ionic formula is I make sure that I've got the same number of positives than negatives. For the sodium, we've got 1 positive inside the bracket, but we've got 2 of those. So the total positive charge that we have is 2 positive. What's the charge for the oxygen? 2 negative. They balance and cancel each other out. This example's a little bit more tricky. We're going to write the chemical and ionic formula for magnesium oxide. So we'll write our symbol, valence, swap, divide formula. Symbol for magnesium is Mg, valence 2. Oxygen, symbol O, valence 2, and swap them over. What's the highest number that we can divide 2 and 2 by to keep it a whole number? This time, we're dividing by 2. This is a really important step because this is the only way that you can get the correct formula. 2 divided by 2 is 1 and 2 divided by 2 is 1. For the formula, we write down the chemical symbol, Mg. How many have we got? 1. We don't write ones after the chemical symbol. Oxygen, chemical symbol O. How many have we got? we've got 1, we don't write the number after the chemical symbol. So the chemical formula for magnesium oxide is MgO. Again, the same steps follow for working out the ionic formula for magnesium oxide. Remember, if you've got ionic formula, you have to make a sandwich and wrap it up. Once we get to the bottom of this, what we can see is that the formula is Mg 2 plus in brackets, O2 minus in brackets. We've got one of each type of ion, so we can get rid of the brackets. What's our double check? Double check that both charges cancel each other out. We've got a 2 positive and a 2 negative. So here I have 8 examples for you to have a go at writing the chemical and ionic formula for. They all end in "ide." Remember, the D stands for double, so we should only have 2 different elements which will be found in the periodic table. So if you want to pause the video, when you are ready, you can resume and the answers will pop up. This question's from the old standard grade 2013 past paper written 19A. The question asks, write the formula for aluminium iodide. The compound ends in "ide", the D stands for double, which means we're going to be using 2 different elements. It's specifically asked just for the formula, so we're going to be working out the chemical formula. We start off with our SVSDF, symbol for aluminium, Al, found in group 3, valency 3. Iodine, the symbol is I, it's found in group 7, valence 1. Swap the numbers over. Highest number, 1 and 3, can be divided by to keep it a whole number, is 1. 1 divided by 1 is 1. 3 divided by 1 is 3. So therefore, the chemical symbol is Al. We don't write ones, so we leave that as it is. I3. This next question is from the standard grade 2012 past paper written 16C part 2. The chemical reaction inside this battery produces lithium oxide. Write the formula for lithium oxide. The compound ends in "ide", D stands for double, that means we're working with 2 elements. We write our SVSDF, symbol for lithium, Li, found in group 1, valency 1. Oxygen, symbol O, found in group 6, valency 2. Swap the valencies over. Highest number both can be divided by to keep it a whole number is 1, which means the chemical formula is Li, and we pop a little 2 after the symbol, O. This last past paper question is from the standard grade 2009 written 10B part 1. Magnesium and chlorine react together to form magnesium chloride. Write the formula for magnesium chloride. We write our SVSDF, chemical symbol for magnesium is Mg, it's found in group 2, valency 2. Chlorine, symbol Cl, it's found in group 7, valency 1. We swap those valencies over. Highest number they can both be divided by is 1. 1 divided by 1 is 1. 2 divided by 1 is 2. So the chemical formula is MgCl2.